We are from MotherDuck. We are a data warehouse company. We are a Seattle-based company, but we have a Dutch entity. So we have a Amsterdam office since the last 2 years, 2.5 years now. We build databases. So we do a lot of research. We do a lot of platform, cloud, and the lot. And then we are building a lot of AI native stuff into our product. So we're going to be talking a little bit about what we do in the AI space. So we recently launched a product feature called Dives. So that's going to be, let me just ask databases in my MotherDuck org. So the journey for integrating AI into MotherDuck started with in 2024 in September when MCP servers launched. So the first we open sourced our local MCP server that helped many users to connect to MotherDuck and query their databases. Unknowingly, we didn't build it as a toy, but it grew in popularity. So it was one of the most popularly used MCP servers in the beginning. So that was already 2 years ago. And we've slowly then built on top of that to kind of see how our customers use our MCP server and build it to become the remote MCP server that it's now today. A lot went into context engineering, tool iteration inside the MCP server, adding more features inside the MCP server. So the way that we're seeing is that we're going to move a lot towards letting our users use MCP server to kind of access the data warehouse, set accounts, set administration and management and stuff. So yeah, this is one of the tools that we have inside the MCP server, list databases. And I'm just going to say, can you create a dive that's interesting with the galactic coffee DB? So let's see this rip and let it explore. I'm going to explain a little bit about what this feature is. So a dive is a dashboard that's being built on top of your database. So for the questions that you ask, it explores. Can you zoom in a little bit? Yeah. Zoom in. Oh yeah, sure. So for the databases that your data warehouse has, it's going to query the database. It's going to iterate on top of the queries. It's going to see what tables are inside the data warehouse, what is inside the tables. It's going to sample the data, and it's going to create a dashboard. So let's see. I guess 4.8 thinks a lot.
It's doing this?
Yeah.
Is it something that only I can use as a MotherDuck user, or also something I can surface to clients, for example, so they can?
Very, very good question. So you could do both. So you could let your client connect to the database that you have provisioned for your client to build a dashboard. We call it a dive. Or you can build your dive and embed the dive inside your application so your customers can use it. So you can do both ways as well. So we call that embedded dive. Yes. So now it's build the dive, and yeah. So you can also embed the dive in your application. Does that answer your question? Perfect. So while
what does this galactic coffee?
it's just a sample data.
Okay.
Yeah. So maybe a little bit of an introduction about us too. So I work at MotherDuck as a platform infrastructure engineer, and Niclas here.
Yeah, I'm a member of the database team, so I'm working on a core database, which is in this case DuckDB, and making it kind of cloud ready. And as you can see here, we basically just prompted that we want to see something interesting with the data set. What it managed to do is it gave us, it generated some kind of graph and showed us that there's a seasonal pattern in the data and when how much coffee is sold. Apparently, there's more towards the end of the year, which makes sense. It's cold. You want to have coffee if it's cold. And while this is all nice and well, it works within Claude. What you can do is it also automatically gets deployed to MotherDuck as well. So you have your visualization within Claude, but now if you open our MotherDuck UI, you can also see this is the visualization it created before. And unlike most dashboards you just create within Claude, this is an actually 100% interactive integration which relies on live data. That means in the background it's gonna refetch all things. I actually built a small presentation in one of these styles, just Claude and me vibing, trying to explain a bit better what dives are and how you can use them. So let's go into presentation mode and give you a bit more background. So first of all, we're using DuckDB internally. What is DuckDB? It's a database. It's basically like SQLite in a sense that it is in process, but it is for analytics, whereas SQLite is really for transactional workloads. You just insert something, you get it out. It's more of a database for CRUD apps. DuckDB really excels at big data, like terabytes of data. But sometimes just having a DuckDB on your local machine is just not enough, and that is when you kind of need MotherDuck. And using MotherDuck is really as simple as kind of using DuckDB. First of all, you import it, and then you attach to MotherDuck, to whatever data warehouse you have already existing, and then you can start querying. And the cool thing about MotherDuck is that you're not only using your local DuckDB database that you already have, you also use the cloud. So they kind of work collaboratively on executing your queries and answering your questions. Yeah, and it's built for the cloud. You have one DuckDB instance per user, which is really neat for agents because you don't want your agent hogging up all the compute resources of your database, making all the other things slow. So each agent gets their own DuckDB instance in the cloud. You have zero copy, which means that if you want to clone a database, you don't actually clone the data. You just clone a reference to the data, and it's really fast. It's free because you're not copying data. It's just reference copying. And all of these tools make it really nice for agents to interact with it because you can just give them a copy, tell them to run wild on that copy. They might drop something. They might update something really terrible, but you don't care. It's not your data. It's just a copy of your data. And whenever you feel like it, you sync it back. So yeah, what are dives and how do they really work internally? As you have seen, the agents are really the driver. Dives are not meant to be created manually, handcrafted React code. You basically chat with Claude or any other agent, and they will do what you've seen before. They will first query your data. They will look at what is already there. Then, and I think that's the most important part, they actually look up what is a dive, because in the beginning they don't really have a concept what a dive is, and that is where we kind of tell them how to create a dive and how to interact with dives. And then lastly, they create a dive, which is what you've seen in the end, where you had this nice diagram showcasing you different things. And I think, as you all know, agents are nice, but without evaluation or something to guide them, they can kind of go everywhere and nowhere. So what we do is when Claude Code, or any agent for that matter, creates a dive, is we first validate that the dashboard they have created actually makes sense. That means we parse the JavaScript, we create an AST, we extract the queries they're using internally, and then we validate the queries. See if they parse, see if they actually make sense. And only if all of these steps have been completed, then we upload the dashboard to MotherDuck. If any of the steps don't complete successfully, we go back, tell the agent to update things, and normally self-corrects and fixes it. So as you've seen, we host the basically untrusted code that someone vibed on our website. Might seem dangerous, but Actually, it's not. Because what we're doing is we're kind of sandboxing all the content that is user-generated in an iframe, and then only allow certain interactions from within this sandbox. That also means that if someone is sending you a dive and you're opening it and you're running that code on your laptop and on your data warehouse, it has to be safe. That means we validate the database queries, we parse them, we inspect the query tree, we make sure that there's no one sending you a drop database statement messing up your data warehouse. And I think this is also where hybrid query execution comes in. I mentioned before that your client-side DuckDB and your server-side DuckDB kind of work jointly on executing queries. This is because you have a database on your client as well. It's an in-process database. And this is the same as the case for all these dashboards that we showed you before. This here contains a database compiled to WASM, which means that once the initial load has happened, you cache all the information locally, and then you have a local database which is able to answer all your queries locally. You don't need to download anything. You can drill down without executing anything on your data warehouse. And that makes it really fast and snappy. So, thank you. Yeah. I hope I wasn't too long.
Just a quick parting note. We're always hiring. We're currently looking for engineers. So if anybody's interested across databases, platform, AI, agents, please
literally
reach out.
Anything engineering.
Anything engineering, yeah.
Yeah.
We can share this. Thanks for your talk. Pretty interesting to see, basically the SQLite for analytical data. But I'm wondering, usually you need pretty beefy hardware for running these big analytics queries over huge amounts of data, right? So I don't really get the part where, you have a locally running DuckDB in your browser, but where's the actual computation happening?
So what is happening is, as you said, you have this local database. Okay, so you have the local database, and this connects to your data warehouse. The way we connect with it allows the query, and you select star from something. That query is going to run wherever it makes the most sense. So if it makes more sense to run it locally because all of your data is locally available, then it's going to run locally. If you have remote and local data, it's going to split the query execution between local and remote. And when you said, analytical queries are heavy and you need a lot of compute, that is true, but I think DuckDB does a really wonderful job of just making big data feel super small, and you can run joins on hundreds of gigabytes, even terabytes on your laptop, assuming you can fit that much data on your laptop hard drive.
2 points to add to that. The misconception that local compute is not good enough has changed a lot in the last 10 years. Your MacBook Pro, I don't know, M1, M2, M3, latest generation is probably 100 times faster than the server node that you had in AWS 10 years ago. So all the data warehouses that were built 10 years ago had this distributed system where one query could not run in one single node, so you had to kind of distribute all the load across different servers and then bring that result back to the single server. But we believe that the way that we've architected our data warehouse is one single node is a lot more powerful, and our laptops are also super powerful. So it lets you scale from going from local to the cloud really smoothly.
Feels almost like the storage is more the bottleneck. If you're talking about 100 gigabytes,
yeah.
I don't have 100 gigabytes free in my MacBook.
Yeah. So DuckDB does something interesting. So it does not need to store all the data in the memory. So it does something called spill to disk. Any data that it does not need to store in memory right away, like when you're doing joins, when you're doing aggregates, right? It writes the data into disk and then reads it back when it actually needs it. So it kind of manages memory really, really well in that case. And to your point about data sizes, yeah, in data warehouses, you do have 10 terabytes of data. But last year, there was research from Redshift, like 95% of data warehouse workloads are less than 1 GB.
Yeah. Well, they touch less than 1 GB of
They
data.
touch
Yeah.
less than 1 GB.
That
so
mean,
it's like,
yeah. That means they're just skipping over a lot. You know, your table might be 10 terabytes big, but you're realistically only interested in, you know, last week's sales. So, you know, there's a lot of data that you're just not interested in reading. Any more questions?
you had a question.
You had a question?
Well,
You want?
I was kind of wondering at what size does the model break down actually? What is the maximum size you can easily handle in general?
Like the data?
The database and the MCP and the whole stack actually.
Yeah, that's an interesting one. So for MotherDuck, we have different compute sizes. So usually we recommend customers when they're doing agentic stuff to run like small size of compute. But we do scale. We have like small, standard, pulse, jumbo, mega, and giga, like for like very, very big workloads. For some workloads, we have multiples of gigabytes of RAM. Terabytes of RAM, sorry, of RAM. So that on the data side, that's the case. On the agent side, when you look at tokens, that's still something that we're optimizing.
Does it all go through tokens?
Yeah. So we're trying to see how we can sample the database better and how much we can truncate the data that's sent to the when you're creating a dive, for example.
What exactly was your question regarding is it all tokens?
Well, you have a, sorry. No, I mean, what was the limit? Where does the model, so your stack basically reach the limit? So you partially answered that. But it all goes through tokens as well. So if you, I suppose if you send petabyte.
Oh no, we don't.
no,
we don't
yeah.
sell data.
Yeah. So if you know the MCP protocol is a lot more lightweight. We would never send 1 terabyte of data to Claude. I think they would be also very unhappy about that.
So Claude generally writes the query
Yeah.
to then build the dashboard.
Yeah.
So
And then you
this
just
particular dashboard has only the SQL queries.
Yeah.
It does not have the data.
Yeah,
So
if you look at the source code, you'll see that, you know, it's only, I'll zoom in a bit for you. See, there's no data hard-coded. It's just SQL queries. So it's kind of lightweight. Okay.
we are around till the end, so just ask us questions for later. Yeah.
Yeah.
Thank you.
Thank you.